Okay, record.
Hi friends, I am Noor and this is my friends Lakshmi Narasimhan and Hariram. Now we are going to demonstrate the project about liquid metal battery for a powerful inverter system. The liquid metal battery, when combined with today's inverter, system can meet the demand of domestic supply with any disturbance. The inverter is based on a PIC microcontroller that has been programmed when to get tripped and off the supply and when to supply the loads. The liquid metal battery, when compared to the other batteries, temperature is 1500 degrees Celsius, lifetime 50 years, cost 3000 to 5000 for 1 kilowatt system, maintenance nil. So we could say that this battery can change the powerful need of any country for a lower to higher profit profile at lower cost. Now my friend Lakshmi Narasimhan will explain about the working.
Hi, I am Lakshmi Narasimhan. I am going to explain about the working principle and the components description on the kit. First, let's see the components in the kit. We have a transformer that is 12 volt to 230 volt output transformer, AC. It gives an AC output. It has 1000 microfarad capacitor, 0.22 microfarad capacitor, a voltage regulator, 100 microfarad capacitor and 0.01 microfarad capacitor. Two N MOSFETs, those are STP 55 NF06L, which has an output for, this gives an output for 500 kilowatts, 500 watt system. And then we have a microcontroller, PIC microcontroller. This is PIC 16F628A, and the resistors we have. And then we have a 47 ohm resistor too. So let's see the components working with a fuse. We have HRC fuse. This is HRC fuse of 35 amps, which is used to protect the system. Here the positive wire and this blue wire indicates negative. This is connected to the battery. When this both are connected to the battery, a 12 volt input is given directly to the voltage regulator. This voltage regulator is an 5 volt voltage regulator, LM78L05 volt. So this 5 volt voltage regulator regulates the 12 volt DC output into a 5 volt DC output and gives it to the PIC microcontroller. The PIC microcontroller needs a 5 volt DC input to operate, and it has an inbuilt clock, two 8-bit clock and one 16-bit clock. So using this clock, it also produces an 50 Hz frequency according to the program it has been done, which has been burnt in the PIC microcontroller. After then, this PIC microcontroller converts this 5 volt DC output into a 10 volt DC output, and it gives it to the MOSFETs, and the frequency is injected separately. And when this MOSFET is connected to the PIC microcontroller, it converts this 10 volt DC into a 10 volt AC output, and it also injects the frequency that is coming from the PIC microcontroller into the output AC output waveform. And then this MOSFET is connected to the transformer. This transformer actually converts this 10 volt AC output with a 50 Hz frequency into a 230 volt AC output with a 50 Hz frequency. So you can see the this fuse, HRC fuse, is for protection of the system, and sometimes the transformer emits ripples. Those ripples will damage the PIC microcontroller voltage regulator and they will get burnt. So in order to prevent from that, we have connected this 1000 microfarad capacitor, 0.22 microfarad capacitor with a 470 ohm resistor to safeguard the voltage regulator and the PIC microcontroller. Now Hariram will continue the conclusion.
Overall, our proposal to be implement this system for improving the power utility to maintain power factors. It will use to protect the electric equipment by means of maintaining the frequency constant with modified sine wave output. In future, we can be installed with liquid metal battery. It can also be done for higher ratings power. Thank you.